Okay, so I was trying to say before, we have our four quadrants here. We have our ASTC rule, and in this quadrant, they're all positive. Sine's positive, cosine and tangent are negative. Here, tangent's positive, sine and cosine are negative. Here, cosine is positive, sine and tangent are negative. And so that's also true for the reciprocal functions as well. Okay? So let's say that we had our axes, and let's say that we had this circle here, and let's say we had a coordinate point out here that was -5, -4. And I wanted to know the sine, cosine, and tangent at that coordinate point. So first of all, I'm going to fill in what I have right here. This side of the triangle is going to be -5. This side of the triangle is going to be -4. So now I'm going to use my Pythagorean theorem to figure out what is going to be the length of my hypotenuse. Now the radius is always going to be positive in all of these cases. So I'm going to use my Pythagorean theorem. I'm going to do the square root of, and I'm going to do -5 squared plus -4 squared. And I'm going to get my answer of 6.4. Really what I want to do though is I want to leave it in nice square root form. So it's going to be 25 plus 16. So that's going to be the square root of 41. So this has a length of the square root of 41. So now I can figure out all of my trig functions. The sine of this angle here, which is going to be my reference angle, because now I always go back to the x-axis. Sine of that angle is going to be equal to the opposite over the hypotenuse. So that's going to be -4 over root 41. Rationalizing my denominator here, I'm going to do root 41 over root 41. So that's going to be -4 root 41 over 41. Cosine of theta is going to be equal to the adjacent over the hypotenuse. So that's going to be -5 over the square root of 41. That's going to rationalize into -5 root 41 over 41. The tangent is going to be equal to the opposite over the adjacent. That's going to be -4 over -5. That's going to turn into positive 4/5. And then for the reciprocal functions, you can just flip these three.